All right, now it's time to start learning how to actually go about solving tougher and tougher equations. One thing I want to talk about first is the idea of an inverse operation, which is going to be so important. So every operation has an inverse, and there are lots and lots of operations. We're going to talk about just a few right now. For instance, the inverse of addition, I bet you can imagine, is subtraction. The inverse of multiplication, I bet you can imagine, is division. And I want to talk about this a little bit more in depth for a moment. So for instance, look at some of these examples, right? I've left a lot of blanks and I haven't given you a lot of direction on what to do. So I'm going to go ahead and walk us through this. For instance, the first example I want to give is -7 plus 7 equals 0. And I want to bring your attention to the bottom of the screen for a moment, which says when you add additive inverses together, you get the additive identity. Now, it's a lot of big words. What does that mean? -7 and +7 are called additive inverses, right? And it kind of makes sense. And 0 is called the additive identity. Additive inverses are kind of opposites of sort. I don't like to use the word opposite. I like to use the word additive inverse. When you add them together, you get 0. 0 is called the additive identity because when you add 0 to anything, you just get itself. So -7 and 7 are additive inverses. 5 and, can you guess, -5 are additive inverses because they add to 0. So I want to make a note here that we had said before that the inverse of addition is subtraction. You could also say that the inverse of addition is just adding the additive inverse, right? Adding -5 is kind of like subtracting 5. So, we can talk about addition and subtraction as being inverses, but you can just add the additive inverse. I'll show you a lot of examples, don't worry about it. Same thing with multiplication and division. I'll be honest with you, this is a symbol we are not really going to use this year. And in fact, I don't really ever do division. I like to use multiplication. Let me show you what I'm talking about. Let's look at our first example. And I'm going to write 8 divided by 8 equals 1. All right, that's no surprise. Equivalently, is there a number we could multiply 8 by in order to also get 1? Maybe you've got it. 1/8. And that's what I really want to focus on for a moment here. And I want to draw your attention back to the bottom of the screen that says, when you multiply multiplicative inverses together, also known as reciprocals, you get the multiplicative identity. Multiplicative inverses are numbers that when you multiply them together, you get 1, right? 8 multiplied by 1/8 is equal to 1. 1 is called the multiplicative identity. Why is it called the multiplicative identity? Because when you multiply 1 by any number, you get that number itself. Okay, let's take this a little further. 2/3 multiplied by what number will give us 1, right? And -1/5 multiplied by what number will give us 1? Can you figure it out? Well, like we said before, the multiplicative inverse, which is kind of a big word, also known as the reciprocal. Maybe you've heard that word before, reciprocal. Oh, all right. Well, the reciprocal of 2/3 is 3/2, right? And 2/3 multiplied by 3/2, right, we're going to get 1. You're going to get 6/6, also known as 1. All right, what number goes here, right? What number is the reciprocal of -1/5? It's -5. Right? -1/5 times -5 will give +1. All right. So again, just like with addition and subtraction, right? The idea that the inverse of multiplication is division, I get it. But what we really like to do is, if you're going to talk about the inverse of multiplying, it's kind of just multiplying by the reciprocal or multiplying by the multiplicative inverse. This is all a little abstract right now. Let's put it to use in a few examples. All right. So for instance, we're still kind of dancing around the central idea. If you start with the number x and you end up with x plus 5, you certainly got there by adding 5. No surprise. If you want to go back, you can just add -5 to get back to your original x. Right? Similarly, if you went from x to x minus 8, well, you probably did that by subtracting 8. If you want to go back to x, let me write that 8 a little bit more clearly. If you want to go back to x, all you need to do is, well, add 8. No surprise there. If you started at x and ended at 3 times x, well, that happened by multiplying by 3. If you want to go back to x, you can multiply by 1/3. Some people like to say divide by 3 here, and I get that. I'm really not into division. I mess up a lot when I do division, so I'm really into multiplication instead. Similarly, if you started at x and you went to 2/5 x, well, that probably happened by multiplying by 2/5. No surprise there. If you want to go back to x, multiply by the multiplicative inverse, the reciprocal, also known as 5/2. If you started at x and you made your way to x over 4, x divided by 4, right? That happened by dividing by 4. That really happened by multiplying by a fourth, right? Being really good about talking about multiplication and division interchangeably is going to be really important. To go back to x, just multiply by 4. Last example, if you start at x and you make your way to negative 2x, well, that happened by multiplying by negative 2 times negative 2. And if you want to get back to x, multiply by negative 1/2. Okay, now it's like, Benji, why are we doing all of these examples? What's the deal? Now let's talk about using these skills to actually solve a few equations. So take a look at a few at the bottom. Now these ones I know you can solve with your intuition, but I want to ease us into the idea of how to go about solving more and more difficult equations. So our first one, x plus 5 equals negative 12. I bet you can find the solution to that with your intuition. But I want to talk about using these inverse operations to our advantage. Okay, so one key idea that we always have to keep in mind is that if you're dealing with an equation, whatever you do to one side of the equation, you must do the same thing to the other side of the equation. Whether that's adding a number or multiplying the whole left side by 7 and the whole right side by 7, whatever it is, you got to do the same thing to both sides of the equation. So in this case, I see a situation here very similar to what I saw up here, right? I see an x plus 5, but I want to have just an x. I want to know what x is equal to. So I'm going to add negative 5 to the left-hand side because I know that if I add negative 5 to the left-hand side, I'm going to get a situation where this negative 5 and this positive 5, they're going to add to 0. I'm going to get just an x. Of course, like it just said, whatever I do to the left-hand side, I must do to the right-hand side. We find that x equals negative 17. That is the solution to this equation right here, and you can substitute negative 17 in for x, and you'll see that it works. Great. This second example, very similar, looks a lot like what's going on up here, right? So I have an x minus 8. I prefer to have just an x. Okay, so what I'm going to do is I'm going to add 8 to the left-hand side. Got to do the exact same thing on the right-hand side. We end up with x equals 29, which is the solution to that equation. Again, I'm sure you could have done this with your intuition, but we're just easing into this idea. All right, next slide. Now our equations are looking a little tougher, maybe not too tough. Here we have 3 times x equals negative 15. I bet you can solve this with your intuition, but let's go through the motions of practicing our new skill. I have a 3x on the left-hand side. I want a 1x, so I'm going to multiply by the multiplicative reciprocal of 3. I'm going to multiply by 1/3. Right, so 1/3, I know that 1/3 times 3 is going to give 1. I'll have 1x. I'm even going to write the 1 there. And of course, what I do to the left-hand side, I must also do to the right-hand side. I like adding all these parentheses. It helps me make sure I don't forget anything. Negative 1/3 times negative 15 is 5. So we have x equals 5, which if you did this with your intuition before, I bet this is what you got. All right, just a few more examples. I wanted to do this one on the upper right, negative 3x equals 11, to show that our solutions are sometimes not going to be nice integers. Right? It's the exact same sort of strategies we did on the upper left. I think I'm going to multiply both sides by negative 1/3 now. Negative 1/3, I chose that because negative 1/3 times negative 3 is just going to give 1. So I have a 1x equals, let's see, times negative 1/3. I get negative 11 over 3. Okay, couple of things, really important. One, I got to say, decimals are great, but in the context of this unit, I think fractions are going to be a lot easier to work with than decimals. No need to extend that out forever and ever. It's not so bad when our denominator is 3, but if our denominator was 7 or 13 or who knows what, you get a really nasty decimal, go ahead and leave it as a fraction. And you know what? I'm okay with improper fractions. We should know that, yes, this is equal to negative 3 2/3, but this is fine. And I just wanted to show you that sometimes our solutions are going to be fractions. All right, last two examples. Maybe you want to try them on your own before we do them. I don't know. 2/5 times x. I don't want 2/5 x. I want just 1x. How am I going to get there? I'm going to need to multiply by something, the reciprocal of 2/5. So I'm going to multiply both sides by 5/2. I'm going to multiply the right-hand side, of course, by 5/2. 5/2 times 2/5, that equals 1. Fantastic. So we have just a 1x there. On the right-hand side, 18 times 5/2. We got to be good with our fractions. I'm going to call this 18 over 1. I'm going to do some simplifying as we go. Let's see. 1, 9. I think 9 times 5 is 45. All right, so x equals 45. Fantastic. That is the solution in this case. Last example here. X over 4 equals negative 3. It's a little tricky. This is also x divided by 4. You can also think of this as 1/4 times x. Oh, in that case, the thing to do is definitely to multiply both sides of the equation by 4. We end up with our solution x equals negative 12. So what I really want us to take away from this is that, yes, there are a lot of tools we can use to solve more and more complex equations. You can also rely on your intuition. But this particular lesson was all about using these inverse operations to solve more and more complicated equations.